Very good morning to our today's expert, Dr. Dilip Singh Sisodiya, sir. He is currently working in NIT Raipur. I welcome you, sir, on behalf of the organizing committee, Department of IT, Shri
Thank you, ma'am.
Shankaracharya Technical Campus, Bhilai, on this FDP, which is on data analytics and visualization tools.
Thank you,
So I
ma'am.
thank you, sir, first of all, for accepting the invitation and giving your consent for giving this lecture. So thank you once again, sir, for accepting our invitation.
Okay,
And I
most
welcome
welcome.
you, sir. Welcome, dear all participants. A very good morning and a very happy Merry Christmas to you all. So welcome for today's session, which will be given by Dr. Dilip Singh Sisodiya, sir. He will be covering the topic data modeling using machine learning algorithms. So I, on behalf of organizing committee, welcome you all. I welcome Dr. Dilip Singh Sisodiya, sir, and dear all participants.
Okay.
Now I hand over the session to sir.
Thank you, ma'am. Good morning, everybody, and my greetings for Merry Christmas to all of you. And I welcome you all in this session. This session is about we will discuss this data modeling techniques using machine learning algorithms, and preferably we will discuss two algorithms: naive-Bayes algorithm and decision tree algorithms. These are some popular algorithms in which is used for data modeling. So, first, before starting, I would like to pose a question. There is always, we can say interchangeably, we will use two terms. One is algorithm, one is model. Because here, first is data model. So, data modeling can be different from different perspectives. From database or data warehouse perspective, data modeling is different. From machine learning or analytics point of view, data modeling is different. So first, the learning. What is learning and why we learn? So there are some tasks like this calculate the payroll. So which is not need to learn, because here we have to explicitly compute each and everything. Or what it means, we cannot generalize the learning. Suppose we did X computation or for X person, it cannot be generalized for Y. So some tasks for learning is no learning is required. This is one example. And what is learning? Learning is any process by which system improve performance from experience. And for any system, this learning may be applicable. It may be applicable to us also. It may be applicable to computer also. But how to learn? And for that, we need some experience. What is this experience, and from where we? So obviously, over the period of time, knowingly or unknowingly, we gain experience. We encounter to different situations and gain some experience and learn. So, in case of models, or in case of data models, or in case of machine learning model or anything, how this learning will perform? Obviously, this learning, this experience is nothing but the data, whatever data we are presenting to the model. If the quality of this data, accuracy of this data, or the if this data is well represented, then obviously the learning will be good. So the experience is represented in machine learning paradigm. This experience part is represented by hello.
Yes, sir, you are audible, sir.
No, I am audible, ma'am, but I would like to request some participants are not muted their speaker, and I am getting a
Okay,
disturbance between.
okay, sir. Okay, sir.
So please ask them. Okay, thank you. Now it's perfect. So, and in machine learning, or this learning through data or through experience is used when there is no human expertise or human expertise does not exist. So there are situations where human expertise the totally unknown. So we can use this navigating on Mars, or we can train or we can fit this learning into robots, and these robots can be deployed on such type of unknown places. Humans are unable to explain their expertise, then we have to, like this speech recognition, why we are recognized. So it's speech recognition is a complex process. So this process can be explained mathematically by this model. Solution changes, it means the process is solutions are dynamic, changing over the time, and it is very difficult to track. Then this learning, this automatic learning is helpful, and if solution needs to be adopted from particular cases. So so these are the some situations where learning can be very helpful. So what we talk about when we talk about learning, so learning general models from the data of particular example. So first we will collect the data of particular example, and this data is presented to, or this data is used to prepare a model, and then we generalize the behavior of this model. Although this machine learning is not a new term, or this learning is a integral part of artificial intelligence along with the other tasks, and this learning portion is taken care by this machine learning. So we can say the machine learning is a branch of artificial intelligence or subfield of artificial intelligence where we insist on learning only, while the other, like common sense reasoning, knowledge representation, and game playing, natural language processing, there are so many other fields of AI. So out of these, only this part will be taken care. So this machine learning is not new field. This machine learning term was coined in 1959 by the author Samuel in his paper, seminal paper, first time. But nowadays this machine learning is, or this learning task is, because earlier all the things, all these algorithms are very old algorithms, but there were no use of this algorithm, because all these algorithms, the algorithms, and before going to, I would like to mention one thing. There are two terms interchangeably we use. One is algorithm, another is model. Okay, both algorithm and model. Both algorithm will also use the data, model will also use the data. But there is a difference, or we can say the slight difference between algorithm and model. So when instances or data are presented to any algorithm, this algorithm will train, and after training, this algorithm will be, after training, there will be a model. So the difference between algorithm and model is, algorithm is a set of instructions. When we train this algorithm or we present lot of data, then this algorithm will convert into, or a model will be trained. So means lot of data is required, and earlier there was no availability of data because of nowadays the data generation as well as data capturing technologies have tremendously improved. So that's why this machine learning and all these things are gaining popularity or used extensively, because all these models are data driven models. Training data, if we are using algorithm, then we have to present lot of training data, and for model we have to present the test data. So nowadays data is cheap and abundant. Data is available in form of data marts, data warehouses, or in form of big data. But knowledge is expensive and scarce, and this is a challenging that out of these large data houses, the size of these data houses are in uh, in petabytes. So terabytes, petabytes, these are the normal common size. So out of these huge data warehouses, data marts, or out of these big data, it is important to extract the useful information or knowledge. So data is cheap and abundant, and just because of its the availability of data, this machine learning or these models are gaining popularity. So one example is customer transaction. For consumer behavior, people who bought Da Vinci Code also bought the five people. You may be heard about the recommendation systems. So this is the case. This recommendation system is also example of machine learning technique. So where these e-commerce portal like Netflix, Amazon, YouTube, extensively using this technique to recommend content or product to the users out of these large data sets. So build model with good and useful approximation to the data. Our objective is to building a model which will approximate the behavior or general behavior. Uh, uh, there is a difference between traditional programming and machine learning. And in traditional programming, we use the program and data. So program is set of instruction and we present data, and this program will give us output. But in case of machine learning paradigm, here data is presented and output. Our output, or we can say we defined our goals, our objective. Just suppose this is the customer transaction data or the telephone subscriber data or telephonic services subscriber data, and we want churn prediction, or we want to the list of those customers who are loyal to the company. So company can extend bonus or some benefit to such type of customers, or some customers which are not loyal to the company and very soon they are going to leave this company. So company can offer them some new product or some new discount, so company can retain such type of customers. So what for this such type of problems will company will give the customer data and the objectives. These are the objective from data, and now out of this data, this machine learning will give a set of rules, or we can say the program. So here the difference in conventional programming or traditional programming, we present program, we use program, and this data will be passed to this program and it will give output. But in case of machine learning, we use data and give certain objectives, what we want to extract from this data, and your machine learning program will or machine learning model will give a program or set of rules or set of instructions. How? So this is the difference. These are some classical definition of machine learning. So machine learning is a science and art of the programming computers, so they can learn from the data. Or machine learning is a field of study give computers ability to learn without being explicitly programmed. So these are some we can say the classical definitions of machine learning. One is this computer program. Machine learning is defined as a PTE. Computer program is said to be learned from experience E with respect to some task T and some performance measure P. If its performance on T as a measured by P improve with experience E. So well-defined learning task is given by P, T and E. So these are some definitions. Now come to the terminology. Like we have seen, one terminology is what is difference between algorithm and model. Similarly, in machine learning is totally driven, or machine learning or data models are prepared by using data. So data is very important, and how to represent this data. So there are terms are used like instances or tuple. So this data may be two-dimensional data, three-dimensional data. Data may be sometimes very structured in form of rows and columns. Sometimes it may be image. Sometimes it may be a web page. Sometimes it may be a text data, or sometimes it may be signal. Sometimes it may be voice. It can be a voice signal or it can be anything, means from very structured to very unstructured. But we have to prepare the whole modeling, the whole data modeling concept is around to use how we can use this data. So first term is instance, or we can say the tuple. So a single row of data is called instance. When we represent this data in two-dimensional form, then one row is known as instance, data instance, or tuple. Or the second term is feature or attribute. So the columns are known as features or attribute. And there is a slight difference between feature and attribute. Attribute may derive the multiple features. From single attribute, we can derive a multiple feature. Like salary is a attribute, or our age can be an attribute. But what are the possible features from this salary or age? The salary age means what is the maximum salary, minimum salary, standard deviation of salary, or in this way means many numerical quantities can be, or many numerical values can be derived from the same attribute. So these attributes or features are represented generally interchangeably. We use this feature and attribute, but there is a slight difference which I have mentioned here. So these features are represented as a column. So generally, in simple words, in machine learning problem, the data is represented as a two-dimensional, some rows and column, and this data will be presented. So if your data is very complex, then first our objective before modeling to the problem, our objective should be how to imagine this data. And just suppose we are working with the EEG signal or ECG signal, or suppose some face recognition problem. Then how EEG signal will be converted? So anyhow, we have to extract some features from the EEG signal by applying some pre-processing technique, and then it will be converted into 10 number of signals, or 100 number of signals, or 100 number of subjects, and 10,000 if we are taking the sample, 10 samples from one subject, then 100 into 10,000 samples, and now we extract the attribute. So this is the instances, feature, attribute, data type. These attributes are attribute or features are represented by data type. It can be anything. It can be string, it can be dates, it can be time. Just suppose we are dealing with natural language processing, then it can be some words. So date, time, numerical, or some complex data. But these data are reduced to real or categorical values when working with our traditional model. It can be anything, but we have to reduce in form of either categorical or some real values. So data set, the collection of instances, is known as data set. When working with machine learning model, we typically need a few data set for different purposes. Training data means the part of data set which feed into our machine learning model to train. So this is known as training data. Another is known as validation test, validation set. Training set means this data set is generally divided into three parts: training set, validation set, and testing set. So validation, if suppose we are using some algorithm, a lot of hyperparameters are there. So just to tune these hyperparameters, we use the validation test. So data set, if suppose size of this data set is 100, then we will divide this data set into 70, 10, 20. Means 70 is training, 10 is validation, and 20 is testing. Or it can be 70, 15, 15. 15 is validation, 15 is. So 15 instances are used for testing. So training set, which is used to train the model, validation test, which is performed for hyperparameter tuning, and testing set, data set that used to validate or to evaluate the accuracy of our model. So sometimes in some problems you may have seen that the performance is measured on validation test, but it should be generally on test set. But it is some more terminology. So what we have seen algorithm, model, instance, tuple, feature, attribute, data types, data sets, training set, validation set, testing set. Induction. So induction basically a process by which our model will learn. So induction is a reasoning process that makes generalization from a specific information or specific. So this process means the model will learn through a process which is known as induction or inductive process. Generalization, generalization is when model will learn. So generalization means uh, on this learning behavior, how we can, if we present new set of data, then how this learning behavior can be demonstrated. So generalization is required because the model that is prepared by machine learning algorithm needs to make some prediction or decisions based on the specific data instances that were not seen during the training. So what is the performance of model on unseen data set? This behavior or this performance is known as generalization. Overfitting or overlearning, underfitting or underlearning, online learning, offline learning. So overfitting, when model learns training data too closely and does not generalize, means the performance measures are perfect, but model is failed to generalize. So such type of models are known as overfitted model. So the result is poor performance on data other than the training data set. The training um, sometimes people represent that their accuracy is very high, but they did not mention this accuracy or this performance was taken on training data. So obviously training data, if your performance, your model performance is very high on training data, it doesn't mean it same will be reflect in testing set. So generally performance of testing set will be counted. So if your model is performing very good on training data, obviously it is expected model will always perform good on training set. So training data or training data set. So if model is performing good on training data set, then we'll say this model is overfitted model. Underfitted, when model has not learned enough structure from the data set because the learning process was terminated early. This is called the underfitting or underlearning. This result is good generalization, but poor performance on all data, including the training data set. So these are the some terms. Online learning. In online learning, when method is updated with data instances from the domain as they become available. Online learning require method that are robust, because in online learning we are taking data in real time. So this online algorithm should be, any algorithm can be converted into online algorithm, but it should be designed robust to noise data, because there is no time for data pre-processing, or we can inspect the data rigorously. So offline learning, offline learning is when method is created on pre-prepared data, means data set is already available, will perform some pre-processing, we inspect data very well. So such type of learning is known as online learning. So these are some few techniques, few terms which are used. Hello.
हाँ सर सुनाई दे रहा है, इट्स ऑडिबल.
Okay. So hopefully these basic terms will be clear to all participants. If you have any question regarding these terms, you can ask now, so we can proceed further.
Sir, why we use validation phase or validation data set 15?
Okay.
What is this?
Yeah, good. Actually, as I have said that whatever the data we are using for preparing the data model using any machine learning. So general principle is this data set should be divided into three parts: training data, testing data, and validation data. So general assumption is, or generally what we follow, the size of this training data should be comparatively large. For example, suppose we are using 100 instances. So out of these 100, at least 70, it will depend on, it may be 80-20 what we are following, 70-30, it may be 80-20, but the majority portion will be converted, majority portion will be used as a training data. Then the remaining data will be divided into two parts. One is known as validation set. Now your question is, what is the purpose of this validation set? So validation set is used to validate the learning, not performance measure. Validate the learning means there are some hyperparameters. Hyperparameters, do you know the difference between parameter and hyperparameters? Hello?
No,
Anyone?
sir. No, no, no.
Okay. So in every algorithm, anybody else? What is the difference between, you may heard about these terms, we are optimizing the hyperparameter, or parameter is generally parameter and hyperparameter. So in machine learning algorithms, every algorithm use some parameters. Okay. For example, if we are using KNN, it's simplest. But what is the parameter? The value of n. We will pass these parameters n. Okay. So there are two types of parameters. One, which is directly the value of these parameters will directly pass to the algorithm for its working. Okay. And another set of parameters which are not required, but their value will decide the performance of algorithm. So such type of parameters which are not directly visible, like support vector machine. So there are two types of parameter. One is which primarily prima facie we are able to see, and other which will control the performance of this algorithm. So such type of parameters which are not visible or directly we will not provide the value, but their appropriate value will decide or improve the performance of model. So such type of parameter tuning or such type of validation, we use this validation set. So generally the size of validation set is equal to the test size, or it can be lesser than the test size, but it should be significantly less than the training data size. Okay. Hello. Am I clear? Hello.
Yes, sir.
Someone asked this question.
Ah, yes, sir, clear.
Okay.
Yes, sir, clear.
Okay. So validation is just to not generally people also, I have seen in many papers that they show their performance measures on validation set. So it is not good practice. Validation data set is only for just to validate our training is proper, hyperparameters are properly tuned or not. This is the objective of validation set, and it is good practice. Otherwise, commonly people use this training set and test set. But validation use of this validation set is also because most of the algorithms are come with the hyperparameter, and the optimization is a very important aspect of learning. So that's why this validation set is recommended. Any other query? I think no. Okay, so we just recap the important basic terminology of this, how when we prepare a data model. So what is the role of this data? What are the different terminologies we use? Obviously, the model cannot be prepared without any algorithm. So algorithm will be there when when we presented different data samples to the algorithm, then algorithm will only train to the model. So these are some examples, like spam filter. Every day we are using these spam filters when we are receiving mails. So spam filter that flag messages in our email. The recommendation engines, Netflix, YouTube, Amazon, Flipkart, all these e-commerce sites extensively use these recommendation engines to recommend the different products and services. Otherwise, just suppose if recommendation is not there or this learning is, so we will not able to, sometimes we cannot imagine such type of recommendations are presented by these e-commerce sites. Self-driving cars being developed by Google, Tesla, facial recognition in photo services from Facebook, Google's DeepMind for game playing, this AlphaGo computer. These are some personal assistant, Apple Siri, Google Assistant, and all Amazon have their own. So every company, so Win Predictor, this IBM Watson, these are example of all these applications are example of data-driven model. All these activities are happening just because of their training, their learning. The way of learning may be different, but so why use machine learning? Problems for which existing solutions require a lot of hand tuning or long list of rules. Machine learning algorithm can often simplify code and perform better. Complex problem for which there is no good solution at all using the traditional approach, the best machine learning algo techniques can find a solution. Fluctuating environment, machine learning systems can adopt to new data, getting insights about complex problems and large amounts of data. We use the machine learning algorithm. So this is the working of how traditional programming model will work and how machine learning model will work. So I will not go into detail what is this. Here in traditional programming, we'll write the set of rules, and first we will study the domain problem, and we'll write the rule to solve this problem. Just suppose we'll consider the example of this spam filtering. We want to design a model which will automatically filter our incoming emails into spam or ham or the genuine emails. So what can be the traditional approach? It can be, we have to write a rule. If our email will contain this value, this word, generally there are some properties, known properties of spam emails, some offers, some slang, some lottery, some business partnership, some proposals, like this. Such type of terms are frequently used in such. So we have to write and write rules, apply, evaluate. If there is some error, we analyze. The same in machine learning, we will collect such type of words. Suppose we have collected, like we generally use this Enron email data set for email filtering. So collect 10,000 or 1 million emails, extract what are the terms, different terms. Again, it will depend. If our program is based on 10 email only, then it will not capture all the essence of this spam mails. So our data should be very broad, and so for that we can use millions of emails, and out of these millions of emails, so every aspect of our data will capture, and this data, this obviously some pre-processing is required, and now this data will be used to train the machine learning algorithm, and now our model will be prepared. When new email will come, automatically it will extract certain keywords from that email, and it will give it is a spam email or it is a ham. Okay, so this process is now automated. What is the problem with traditional programming? If suppose we have written 100 rule or 1000 rule for detecting a spam email, and obviously spammer will also know that because of this word my emails are not delivering, or they are diverting to the spam folder. So it will change strategy, and again we have to write a rule for this change strategy. But in case of this data models or data driven models or these machine learning models, what it will automatically, if our model is properly designed, properly prepared with sufficient amount of data, then automatically it will, if spammer will use a new keyword, it will automatically during learning it will automatically capture or flag that word. If this word is new, or so it possibly it may be a spam email. Okay, and once on the basis of this flag we have marked this is a spam email, then automatically such type of all emails will be converted to spam emails. So this is the difference between how traditional programming model and machine learning models or data driven models will work to solve any problem, and hopefully it will be clear to all you, just because of that's why I consider this simple, which all people are familiar with this email spamming. Okay, so why nowadays, what is the reason for growth of machine learning nowadays? So First reason is its application. Application in diverse field like speech recognition, natural language processing. Now this Google BERT model is able to almost 80-90% accuracy, able to process the natural language. And you can also, the searching task is also 90%, more than 90% of time it is accurate. We just give input to our in our natural language. Okay, so there is speech recognition, application, natural language processing, this computer vision every day. In some countries even there is no manual deployment. Everything will be checked. There is no traffic police. Everything will be done by, and in our state, our city is also such type of vision systems are deployed on the road. So this computer vision application, I'm talking about this computer vision, this medical diagnosis, computer based. Earlier days when where kids or in college or even in schools at that time, यहाँ पर computer द्वारा इसकी जांच की जाती है. So at that time these systems were expert system, but now the whole process is automated. The whole process now they are not testing. This diagnosis is not done by computer. This diagnosis is done by this intelligent models, this robot control, this computational biology. What I want to emphasize here, the reason behind this growth of machine learning is just because of its diverse application in many fields. You can just imagine any walk of our life and you will find this. So everything means now our whole economy is data driven economy. If we have data and the value of this data, how we can use this data and can generate wealth out of data. That's why these data are attributed as a oil or gold of modern days. And one is its application, just because of why we are able to do, because all these applications are old applications, just because of availability of data in all these fields. Now, because data capturing technology also improved significantly. Now, the trend is accelerating because we are getting, day by day, we are getting improved machine learning algorithms, or we are getting every day or every week we are getting a new model. Improved data capture, the sensor technology, networking, availability of internet, speed, and processing of data by using this fast computer. Software too complex to write by hand, so this software, even this ML process is automated. Now we don't require to design an ML model. Auto ML, a new field, you maybe heard about this auto ML, where this automatically it will test all the, generally what will compare the performance and evaluate. So auto ML is automatically do all these tasks, means the whole machine learning task is now automated with the help of this auto ML. New sensors, input output devices, demand for self customization to user environment. So these are the reasons for growth of this machine learning. The types of machine learning, again this as I already said, this machine learning is a very large field, and it's not subject, even we can say it's a discipline. And in many universities the programs are started already in AI, data science, AI and machine learning, like this, such type of BTech programs are already started. And somewhere people are not even realized to what is computer science. But in computer science there is artificial intelligence. Artificial intelligence is, there is a learning is a one task, and in the learning is a well established discipline. So this machine learning, you can imagine here, it can be supervised learning. So supervised learning is our classification. Supervised learning means where target is also available, means the training data is available as well as target is available to train this model. So such type of learning is known as supervised learning. And the classification, regression task, or classification and regression is example of supervised learning. What is regression? Like house prediction, stock prediction. So what we'll do, 10-year stock data will collected, and because we know what was the value of indices or what was the value of that particular stock. So here the known value of this stock is the label. So if data is available in this format, or for classification, we have collected 100 samples of patients in hospital. The patient is suffering from this disease. So we have known the label. So if the task is classification or the task is regression. So if your label is continuous, means label is like continuous value 1, 2, 3, 4, 5 in this way, means lot of values are there, then such type of task is known as regression task. Otherwise, if categories are there, whether yes or no, or 3 categories, 4 categories, or 15 categories, or 20 categories, it will so such type of task is known as classification. If label is available in category or discrete format, then we'll say this is a classification. If label is continuous data, then we'll say this is the regression problem. So linear regression, polynomial regression, Rees, Lasso regression, many type of decision tree algorithm, classification algorithm like KNN, naive-Bayes, support vector machine, decision tree, logistic regression, and many more. These are some few examples. So this is the supervised way of learning. So one term is supervised and unsupervised. If this label is not available, suppose data is given, but we don't know about label. So such type of task is known as unsupervised learning. So clustering, association rule mining, and dimension reduction. These are the example of unsupervised learning algorithms. So for example, dimension reduction. Just suppose one image file is given and we have to reduce the size, just a zip, .zip, .rar, ये applications use करते हैं just to reduce the compress the file. Okay, so we don't know anything, but automatically it will search these programs or this compression algorithms will automatically search some. If we are talking about the image, so it will automatically find some pixels, and a group of pixels will be substituted by a single pixel or less than. Just suppose 100 pixels will be substituted by 10 or 2 or significantly lesser. So in this way, the size of image will be reduced without distorting the contained information. If information is distorted, then there is no use of this reduction. So this is also example of unsupervised learning. Pattern search or this association rule mining algorithm, where you use this a priori FP growth. So it will define the pattern. If we'll buy this, then probably we can buy this. So the market basket analysis, these are the applications where this market basket analysis. The clustering, suppose unseen, we are not, some balls are given, okay, and we don't know anything. So how will apply the model here? Obviously, model will extract certain features from this ball. So what can be the possible feature? First will be their shape. If all balls means it will be spherical, so this feature will not help very much. Their weights, if because tennis ball weight will different, leather ball will be different, plastic ball weight will be different, like this. Their shape may be same, their color may be same, but their weight may be different. Their texture may be different. So in this way, automatically it will extract such type of features. And on the basis of these features, it will group on the basis of, just suppose weight. So same weight balls will be together. So this suppose weight is more, then it can be a tennis ball or leather, leather ball, which is used to play the classical cricket. If weight is less, then it can be tennis, or it can be size, according to size. So automatically these features will be extracted from the data itself by the model. How it will not miracle? Again, mathematical techniques are available, like this similarity measures, dissimilarity measures, Euclidean distance, cosine similarity, Jacquard similarity, dot product, and there are so many tools, mathematical tools are available to doing this, all these things, and we can or these models can do the same thing. Hello.
Yes, sir, you are audible.
Actually, I am not repeating. Means all these things are covered earlier. Hello.
Not exactly, sir. Not exactly.
No. So, is there is any worth to repeat all these things? Whatever I am doing in this way, or I should skip it?
Sir, you can go as you are going.
Okay. Okay. Okay, ma'am. Thank you. No, because I feel these are too common. So sometimes there may be
Uh,
one speaker is already, the context may be different. Whatever I am discussing, the
yeah,
context may
yeah,
be, yeah,
yes, sir. Yeah,
context may be
exactly.
different.
Yeah,
But
exactly.
yes. So I just to retain your interest or interest of your participant, I just want to ensure this. Okay. Thank you.
Okay,
So
sir.
we have seen the supervised learning, unsupervised learning means how to train the model. So different ways. If data is available in this form, then we can use. If labels are available, if labels are discrete, then this may be the classification problem. If labels are continuous, then it may be a regression problem. If there is no label, then it may be unsupervised. And out of this, if you want grouping, then it may be a clustering problem. So again, there are a lot of algorithms are available, lot of mathematical tools are available to doing this. If we want to search the association between two items or relationship, then the problem is the pattern search or association rule mining. If we want to reduce the dimension, what is this dimension? There are two things again I would like to mention. It may be most of the maybe you are aware, but I like to just one. There are two things. One is feature selection and another is feature reduction. Both are not same. Feature selection is something different. Feature reduction is something different. And these terms, this Disney, PCA, LS, singular value decomposition, this linear discriminative analysis, these are the dimension reduction techniques. So feature selection is filter, vapor, they're hybrid. Okay. So feature selection means if we have 100 attributes, normally we use this 10, 20, 100 attribute, but there are some problems. Like I have mentioned one application, this gene expression. So in these gene expression data of bioinformatics, the number of features are 10,000. Number of features may be 20,000. So if model will prepare on the basis of by using the huge number of features, then you can imagine the complexity of model. So generally what we'll do, but and as well as it is also established, experimentally it is established that all features are not equally useful all the time. So what we'll do, there are two things. Either we have to select the important features, we have to remove the collinear redundant features. So for that we use the feature selection. So in feature selection, we will prepare the rank of all, sorry, we will prepare the rank of all used features. Just suppose we are using 100 feature in our problem. So the 100 feature will be ranked, like a first feature जो सबसे ज़्यादा means which is most useful will be first place, second place, like this. So 1 to 100 there will be a list. But in dimension reduction, the approach is different. In dimension reduction, a group of features will be substituted by this in this PCA. So PCA will in place of 10 features, these 10 features will be represented by some component, principal component. So it will find out the component. Just suppose 100 features and we have given input that we want only 10 components. So these 100 features will be represented by these 10 components only. So these 10 components are equivalent to these 100 features. So this is the dimension reduction. Feature selection is different, dimension reduction is different. So this is about the classical learning. Then the other, now come to the other ensemble methods. What we talked about this supervised learning is these are the individual classifiers. So we can group this classifier. Ensemble means rather than taking the opinion of single, if we take the opinion of group of people and work something on this group opinion, then our decision may be more better. So on the same principle, these ensemble methods will work. So how we can ensemble, how we can group. So multiple, just suppose we are using a single decision tree. So rather than single decision tree, we can use a group of decision tree. And this problem, it can be done? It can be done either by using bagging. It can be done either by using staking, boosting. So staking, bagging, boosting. These are the techniques of grouping individual classifier or individual classifier into group of classifier. So ensemble means rather than using a single individual classifiers, we'll use the group of classifiers. So this what I talk about this single individual decision tree, we can use the random forest algorithm. Their way is different, bagging is different, staking is different, boosting is different, but their essence is same. Here, rather than single, we are using a group. Reinforcement learning. Suppose what we have discussed is either labels are available or labels are not available. So another class of machine learning algorithms where labels are partially available, and this is the most prevailing class because it's convenient to work with the label, but the costing of label is very high. In machine learning problems, the labels because most of the data are already labeled, ready-made data is available, but once we'll go for the labeling, then it is very difficult. So cost of labeling is very high. So machine learning problems, we can use the semi-supervised learning where some data is available in form of with label and some are not available in label. So such type of algorithms are known as semi-supervised algorithm. And now in 2016, this it was predicted that there is a saturation in supervised and unsupervised learning. So new emerging field will be this reinforcement learning, semi-supervised learning, this transfer learning. So Andrew Ng predicted this. So these are the new emerging areas. So one is semi-supervised, the other is reinforcement learning. In reinforcement learning, the working is something different. Here, the model or our program is known as agent, and it will work on the basis principle of reward and penalty. So it will learn from environment. It will learn from environment. If it is positive learning, then it will be rewarded. If it is negative, then it will be penalized. So reinforcement learning, these driving cars, self-driving cars, or we can say the good example of reinforcement learning. So there is no, because every road is different. And when this car will start, so some base model will be there. It will start, it's working, and it will learn. The agent of that auto driving car will learn its surrounding, and on the basis of its surrounding, it will start its working. So reward, penalty, when it will accelerate, when it will brake. In this way, this reinforcement learning. I'm just giving the overview actually. Because these are not so simple, lot of mathematics is required, lot of further understanding is required, but I'm just to give a clue about all these techniques. So this is the working of reinforcement learning, semi-supervised reinforcement, ensemble, and now the neural nets and deep learning algorithm. So neural network is already there. The working principle of neural network is basically mimicking the human brain. So in our brain, the information is stored in form of synaptic strength. So that will be represented by weights. But what was the limitation of conventional neural network? It can be single layer network, or at most theoretically it can be of any layer, but it can be of 2-layer at most. 2-layer, very complex problem, and 2-layer network will take lot of time. So there is the neural networks are already there, but their training, the concept of this deep learning is revolutionized the training of this neural network, and it will emerge in form of convolutional neural network, recurrent neural network, generative adversarial neural network, autoencoder, perceptron net. Perceptron is a conventional. So these are the class of algorithms. But again, if this deep learning is we can say the subfield of machine learning, or when machine learning algorithms will trained in a specific way, we say these are the deep learning, or trained neural networks in a specific way, these are we say the deep learning. So artificial intelligence, machine learning, and deep learning. So artificial intelligence is something very big, something very large, and only one part of artificial intelligence, which is learning, will taken care by machine learning. And in machine learning, only one way of training this multi-layer network. Dynamically, we can add, remove, and so this is known as deep learning. Okay, so this is I just try to summarize what is this machine learning. What are the different ways to design the models? Different ways are there. And now you will ask the question, why, if this deep learning is gaining popularity, then why machine learning? So obviously machine learning, these deep learning models are not, and these deep learning models are not very much transparent. Means what they are doing, it cannot be interpreted. They are doing correct. The results may be correct, but you cannot explain. I cannot explain you how these are doing. Like PCA, we cannot. Yes, we will perform the PCA. It will reduce dimension, improve the performance, but I cannot reconstruct the original dimensions by reversing the process. Okay, so it will do some mathematics, and one more difference between machine learning and deep learning is, in machine learning is basically we use features, or machine learning is this feature extraction, or manually we have to extract, and the feature extraction is a difficult task. Just suppose we are assigned some task, like to predict or to know out of one institute has lakhs of students have passed, and we want to extract something out of this data. Okay, so first we have to extract what features we have considered. Just suppose we are predicting academic performance, and we are extracting feature like what was the color of a student, what was the height of a student, what is, because these features, these are the features, but these are irrelevant to the target problem. What we want to extract, we are not looking for. If we are looking for his or her marriage, then these height, weight, and his complexion, these features may play the role for this problem. But for academic success or for professional success, there is no relevance of these features. So one set of features may be useful on another objective. Another set of features is required for another objective. So manually, and we have domain knowledge, means these features can suggested only by like who have long teaching experience or some psychological experience, or this way. This only such type of people can. So the feature extraction, this handcrafted feature is itself is a very complex task. So in deep learning, this feature extraction process is removed. Now feature will be extracted by model itself. There is no human intervention or manual feature extracting is required. So handcrafted features are eliminated by deep learning model. That's why they are gaining popularity. Although very large amount of data, because data is available, so data is not a problem nowadays. That's why these deep learning models are gaining popularity. Otherwise, in other form, these models are already existing from long time. Hello, is there any query? Hello.
Participants, you may type in the chat box if you are having any queries. I think no queries.
Okay. So we should move forward. So I assume that all these things are clear. Okay. So yes.
I have small doubt, sir. So
Yeah.
any difference between the classification and clustering?
Classification
And clustering. Clustering means.
Actually, there is a huge difference between classification and clustering. classification is a supervised learning and clustering is unsupervised. What it means, if we are designing a model, then labels what should be the exact output. This, if this labels or target is available, then only we can do the classification. And if this target is not available, then we can do the unsupervised learning or clustering. So in clustering, no labels are there. In classification, labels are must.
Okay, sir.
Okay.
Thank you.
So
Thank you, sir.
there is a difference. So this case, because in some books or in somewhere they have written in such a way that people may got confused. So this k-mean clustering, or we can say the DB scan agglomerative fuzzy c-mean, or any type of it, may be object-based clustering or it may be relation-based clustering. Clustering itself is a different thing. Different means we can say the field. So clustering and classification are two separate things. And there is a difference. Any more? Okay. So you can here see, you can just means you can imagine the landscape of machine learning. Just suppose in machine learning, one type of algorithm which are known as decision trees. So here you can see what are the different types of algorithms are available for decision tree. This card, this ID3, C4.5, C.5, this chi-square decision system, conditional decision M5, and this is not the exhaustive list. I can add 10 more algorithms to this category. So decision tree is a class of algorithm, and out of that, tens of hundreds of algorithms are available. Similarly, for dimension reduction, some algorithms we have discussed, you may see here more algorithm like this PCA. Generally, most of the time, dimension reduction means PCA. No, you can apply what is the requirement of your problem. But in absence of knowledge of other algorithms, every time we use this Panacea PCA. Okay, no doubt the PCA is the performance of PCA is very good and far superior most of the cases, but still a lot of options are available. The instance-based algorithm, we are familiar with k nearest neighbor, but these are also example of clustering. Clustering, there are different. So what is the what I want to convey by showing to this picture? This picture is just you can imagine how big is this landscape, how many algorithms are there. Is it possible for anybody to learn all these algorithms, to code all these algorithms? But fortunately, the code is available. Okay, so these are the libraries. These are the libraries, and many people may have used any of one of these libraries. So these are the libraries which are available, where most of these algorithms, what we have seen in previous slides, are already implemented. Just suppose if we are talking about SVM, support vector machine. So this live linear or live SVM, these libraries are available. If we want to work on this NLP, natural language processing, so this GenSim or NTLK, these libraries are available. If we want to work on boosting algorithms, and that to be one is ADA boost, another is the gradient boosting base. So these XGBoost, LightBoost, these libraries are available. We have to use these libraries only. So what I want to emphasize here, if we want to work, then lot of options are available in machine learning. Most of the algorithms we have seen in previously, all these algorithms, in some libraries, some algorithms may not be, so we have to just customize as per our problem, and most of the libraries are free libraries for this TensorFlow, Google TensorFlow, or similarly from TensorFlow, so from Facebook, PyTorch. So there are means competition. These libraries are free of cost available. So we can use any of the, like you maybe use this Weka, Scikit-learn. These are the popular. Some those who are not from computer science or not very much familiar with the programming language. So visualization tool is available like this Rapid Miner, the SAS, SPSS, PS. All these have been changed according to machine learning. So no more they are only statistical model. they have added, or the features have been. So this is anything. Okay. So now the classification of learning models, how we can classify? So again, different way. What data is available? So on the basis of availability of database, we can classify these models, ML models, in supervised, unsupervised, reinforcement learning, semi-supervised, active learning, transfer learning. And how we are getting this data, either it may be online or offline. We have seen what is the difference between online and offline. I think we have discussed all these, but what are the different ways? There is no single way. Type of model, some models may be generative, some may be discriminative, some may be parametric, some may be non-parametric. So generative versus discriminative model, parametric versus non-parametric model. And these criteria are not exclusive. We can combine them in any way we like. So this is the different ways of classifying the machine learning models. These are the some applications. Okay. So I will skip this supervised, unsupervised, and I think, hello. Hello. So I have explained all these things. So I would like to skip all these. Hello. Hello. Hello, madam.
Yes, sir.
Ma'am, if participants want to take, because you asked me, or Dolly ma'am asked me, so there will be a 5-10 minute break.
Yeah, we
Then,
can have a 10-15 minutes break, sir. And
so you can,
then we can resume at 12:05, probably.
okay, no problem, ma'am. Whenever you want to take break, you just inform me.
Yeah, we can have a break right now, and probably then we can resume from 12,
Okay,
12:05.
okay.
We can have a
So,
10-15 minutes break. Yes, sir.
Hello, sir.
uh, okay, okay, sir.
Sir,
Yeah, Mr. I think a
So,
participant has some query. Yes, please go ahead.
yeah, yeah.
sir, I have another another doubt, sir. Can I ask you, sir?
Yeah, yeah, sure. You are most welcome.
Sir, here my one of the DST project problem is like that. Here I'm working on the some type of different noise smoothing, sir. In that I'm using salt and pepper noise for different algorithm for the different densities. Now the filter is working. Okay.
Okay.
Okay, before that, what is my problem means, so in the real time here I am using, I have so much of so many algorithms for the different levels of noises. One algorithm is for 20%, it is greatly working. Another noise, another my algorithm is 50%, it's okay. Next 60%, up to 90% in the real time noises, my algorithms all are work. But my problem is, sir, hello.
Yeah, yeah, yeah. I'm listening you carefully, actually.
Sir.
Okay.
So what my problem is, so by using some type of intelligence, and every time the image having in the real time so much of models, so much of noises. Otherwise, some percentage of noise, 10%, maybe 20%, 30%. But my mission, yeah, how can I predict? Suppose the in the real time, this is the noise. This noise is suitable for my algorithm. That is known as a automatic selection of a different algorithms, whatever may be the algorithms. In that, what type of algorithm is suited for the existed noise in the real time.
Okay, okay, okay.
So,
If
sir.
yeah,
For
yeah,
this
sir.
machine learning, sir.
Yeah, yeah. Please allow me to answer your query if I understood it properly. Your query is, in nutshell, your query is you are working some image recognition project, and
Right.
there are some noisy images are there. You are
Yes, sir.
applying you are applying a set of algorithms
Yes, sir.
classification. You are applying some algorithms, but you are
Okay.
getting different performance or poor performance like this. This is your
Yes, sir.
problem.
Yes, sir. Yes,
Okay.
sir. Suppose
Yeah.
in the real time the image coming with a 10% noise, so directly exist for the low level noise algorithms I have automatically select. I will give some type of recognition. So suppose my here whatever maybe the image is coming with a 10% noise, automatically selects the suitable algorithm for the 10%. I have already
Okay,
done.
okay,
Uh,
okay, okay.
yes.
Got your point. Got your point actually.
Thank you.
But
Thank you.
here uh, there are two. Here multiple things are involved. Only sir algorithm will not solve your problem because you are working with some real-time images. So which noise removing filters you are using? Okay.
Yes, sir. Yes, sir.
So first it will be decided by the quality of image will be decided by those filters.
Yes, sir. Yes, sir.
And
Yes, sir. I'm using
after,
suppose.
yeah, if you are using, suppose you are saying that you have put some threshold value. If
Okay.
noise is less than this, then it will be filtered by this filter. If noise,
Okay.
the threshold is greater than this, then it will use this filter like this. Okay.
Yes, sir. Yes, sir. Yes, sir.
So now this is the means this issue is beyond the purview of machine learning.
Yes, sir. Yes,
After
sir.
filtering, now your image will be converted into this vector format or data format.
Okay. Oh, yes, sir. Yes, sir. Yes, sir.
So first is if you are taking a real time images,
Yes,
then
sir.
this filtering and this filtering as well as normalization of or grayscale converting and all these things are should
Yes.
be there. And
Yes.
then what is your objective? What you want to detect from these images?
So actually, my object is, sir, automatic selection of an algorithm, my filtering algorithm for the different images. Sir,
Okay.
yes, sir. Automatic selection. Suppose, so I have so much of algorithms like already I did, sir. I have. So, but the
Oh,
selection of an algorithm is depends upon the noise, sir. Why? Because the computational complexity is different for different algorithms. So suppose there is a low level noises, maybe five.
okay. Okay,
Like
okay, 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 okay.
my
So,
objective is selection of
yeah, I got your point, and what if I understood it correctly?
yes, sir.
Then this is your multi-class problem actually.
Yes, sir. Yes, sir.
So you are what you are doing just reverse. If there is a noise level is this, then which noise filter algorithm or which noise filter should be used on this
Yes,
if you
sir.
want to this suggestion. So
Yes, sir.
for this you have to divide your classes being suppose up to 10 every 5% interval. Just suppose uh, 5, 10, 15, 20, 25, 30 like. So
Yes, sir.
in this way, multiple classes will be there. If your
Okay.
noise is 5 or less than 5, okay,
Yes, sir. Yes, sir. Yes, sir.
then this particular filter will be used.
Okay. Yes, sir. Yes, sir.
If noise is between greater than 5 but less than 10 or 10 up to 10, then
Yes, sir.
this filter will be used. So first you have to perform a
Okay.
multi-class classification.
Multi-class classification. Yes, sir. Okay.
Yes, multi-class classification because your image will you can convert it into binary also. If
Yes,
noise
sir.
is less than 50, yeah, noise is less than 50% or 20% because
Yes, sir.
I'm not aware about what is the exact level of noise. But if noise is less than this percent, x
Yes,
minus
yes,
or x plus, then you can convert the same problem in binary also, binary classification. But for better, you should convert into multi-class because you are saying that multiple filters are there and on the basis of just suppose your class is your image is input image belongs to class 1, then you define just filters
yes,
for class
yes,
1.
yes, sir.
If your image will belongs to class 1, then this single filter or this set of filters will be used on this image.
Yes,
In
sir.
this
Yes,
way you can do it.
yes. Thank you, sir. Thank you, sir.
Oh. So
Like that, sir. If like that, I am doing, sir. If please correct me if any problem, or just I will explain, sir. So for this, I am using binary classifier, sir.
okay.
For this binary classifier, already I have some type of noise database, noise, some type of noise images.
Yeah.
Every time I will comparing with my input image with this noise images, like that I am using cause similarity or having distance
Yeah,
gap.
yeah. Yeah. Yeah.
If it is anything, suppose I already I'm myself, I know that this is 5% noise. If it is matching with the input image, now you use the my 5% algorithm, filtering algorithm directly use. Otherwise, if your input image is
Yeah,
matched with 10% noise
yeah,
model, it will use
I got your point, but whatever approach you are taking,
yes,
this
sir.
this instance based learning, you are using instance based learning, where what you are doing, you are comparing, you are converted some template, and
Yes.
your input image will be matching. So this technique is very time taking and not
Oh,
recommendable for such type of task. So
uh-huh.
better you go for leave it this KNN and all these similarity metrics. You go for some other clustering algorithm where you design an objective function, and rather than matching an individual image to individual image, you
Oh,
just try to optimize that objective function. Then it will be result will be improved, and the speed will be improved, and everything will be improved.
okay, okay. Thank
Because
you.
what you are doing is good, but it is actually a lot of computation is required. It's very computation intensive,
Yes, sir. Yes, sir.
because image vector is large. Means what is the size of your image vector? Means image is converted into which size of vector?
Yes, sir. That is actually the my image size is 250 by 256 by. Suppose I will
So
take it 256 by
yeah, yeah,
250
it's a
image.
very large actually. So
Right?
that's why this may be the reason. That's why this may be taking a lot of time. Okay,
Sir.
so I will also take 5 minute break, and again we will join.
Sure. Thank you, sir.
Oh,
Thank you very much, sir.
okay, okay, most welcome.
Any other participant, if you have any query? So, sir, we'll be taking a break of 15 minutes. Hello. Participants will be having a break of 15 minutes now. We will resume for the next session from 12:15. I'll be sharing the attendance link at around 1 o'clock. Please note, all of you.